Testing, testing.
And now is it on? Oh, now it's on. Okay, cool. Awesome. All right. I figured out the microphone. What's up, y'all? Thank you very much for coming out. This is Web Geeks. It's always a pleasure to have you. And hopefully you're all enjoying the nice weather and having a lot of fun in getting out and doing things in nature. Getting away from the keyboard every once in a while. That is very important for all of our mental health. As well is socializing and coming out to community events and being a part of your community. This stuff is incredibly important too and really good for your health, just about as good as getting in touch with nature. So, to that end, if anybody is interested in doing more with Web Geeks or other community or meetups or other things out there. There's lots of them, not just Web Geeks. There's quite a few. Please hit us up and let us know. We have a form out there. And Ben, I'm always going to forget the name of the form to sign up if you want to do it. Sessionize. It is Sessionize, yes. And you can let us know if you want to do a talk. You can talk to us if maybe a full length talk isn't really your thing. We can work with you. Maybe we can do like a 10-minute, 5-minute lightning talk, and or if there's just something you're really interested in seeing an event wrapped around, you can talk to us and we'll help create that and put something together. For those of you who are kind of new to Web Geeks, tonight we're going to have a speaker. Last month we had a little bit of a different format. We did you could call it maybe a mini hackathon if you were being generous. I call them, or we used to call them dojos back in the day. More of an idea or a concept of we give you a challenge, you break up into groups, you do the challenge, you come back and show us what you've got. So there's multiple forums, multiple ways that Web Geeks holds events, and there's lots of stuff we do. So if any of that sounds fun to you and you want to just keep coming out, please do. Or if you want to get involved and help us put on those events, let us know. There's tons of room here to help out. We meet the second Monday of every month, and it's always right here. We will additionally do our best to live stream these events, which this one is being live streamed right now, and those are hosted on Twitch, twitch.com/DSMWebGeeks. Those videos stay up for 2 weeks and then it drops off. Yeah, I can't think of too much else to throw out about Web Geeks, but Ben, is there anything you want to say about the space or just in general?
Sure. Thank you. Yeah.
All right. Hi, everybody. My name's Ben. I am a recruiter here at Source Allies, but I've also been co-organizing Des Moines Web Geeks with Justin for the last 3 years, and it's been a blast. So just first want to say welcome to Source. If you want to know more about Source, what we do, what positions are available, I'd love to shake your hand afterwards and have a chat with you. But we're here for Web Geeks right now, and we have pizza for you over there on that table. Usually if there's pizza left, I end up volunteering people to take it home. So eat up, please. If you're thirsty, back here in the electrical room is a fridge where you can grab anything you like. We have a Wi-Fi code over there if you need it. And restrooms are upstairs, right over there. Take a right. And yeah, just thanks for being here. Love to meet you after if I haven't yet. Thanks, everybody. Awesome. So we'd like to welcome Aaron Mund from Source Allies. He's our speaker tonight. Let's welcome Aaron. Aaron, I'll let you introduce yourself.
Is this working? Is it on? Yes. It's really hard to tell from here. All right. Hey everyone, as he said, my name's Aaron Mund. I actually work 2 floors up in the big room, as we call it. Today I'm going to talk about theory of constraints and how it applies to software development. I love. Is it too low? Maybe it's too low. Should I hold it like this? Okay, I could do that. Yeah, thanks. Appreciate it. So yeah, theory of constraints. I love this. There was a book written by Eli Goldratt called The Goal. If you haven't read it, you don't necessarily have to read it, but it's a pretty good book. I really like it. I actually listened to the audiobook not too long ago because I wanted to remember it all. And then I thought I should talk about this. And then Ben said, hey, you should come talk. Fate had it. All right. Like I said, my name's Aaron Mund. My first name is actually, the spelling came from a fantasy book that my mom loved as a kid. So she is a fantasy nerd. I'm very happy that she chose Aaron and not Gollum. I am a delivery consultant here at Source Allies. So basically, I go to our partners and make sure they recognize all the stuff they're doing wrong and hopefully fix it. I really, really love the job. A lot of challenges. I graduated from Iowa State University with a degree in computer science and a degree in mathematics. The answer to this is pi, by the way, if you've ever seen this. The guy did some integration trickery. It's actually two integrals and one is odd, so it just evaluates to 0, and the other is just the integral of a half circle multiplied by 2. So he cheated and made it look really complicated, but it really isn't. But I'm a math nerd, so I had to figure it out. I also recently got my MBA, also from Iowa State University. I love learning, reading books, talking to people about what they're doing, solving problems as much as possible. Starting to work here, I started last September here at Source Allies. I live up in Ames, a lot of commute. I initially thought, what in the world am I going to do? That commute sucks. I listen to books every day. It's freaking fantastic. I've read more books in the last 6-ish months than I had, I don't know, probably 2-3 years prior. So I really love that. I'm a dad, 2 kids, both teenagers. They're a handful, but they're a ton of fun. Very fun to make their eyes roll. And I love board games. The Gloomhaven and all the others that have happened just sort of sucked me away from many other board games. So it is what it is. But I still play them when other people actually want to play something. They don't want to spend 4 hours. All right. So that is me. Yeah. What are we going to talk about today? So initially, I'm going to start with the busyness paradox. This is a dad joke, by the way. It's busyness. Haha. All right. On a scale of 1 to 10, how busy does your organization feel? Just shout out numbers. 8. Super busy, right? 7, 8, 9, 10. How effective is it at delivering value? 1 to 10. Source Allies does not count. In general, the busyness paradox is most companies are very busy, but they have very low effectiveness. This is unfortunately, this is a very common thing in business. In general, the theory of constraints is a way to analyze your business to find where you are wasting time trying to optimize what doesn't need to be optimized and find the places that are best to optimize it. So we'll get into more detail. But the busyness paradox, we feel productive because everyone is working really hard. That's not playing, but that's unfortunate. He's mopping up the ocean. Typing furiously, it's a very busy cat, and attending meetings about meetings, because of course we are. But are we moving the needle on what really matters? Do we even know what really matters? Imagine a feature factory. So this is a company that has a huge backlog with tons of features. Their velocity is going way up, the chart on the right. The chart on the left, it's actually their business value. They're kind of going broke. It's not great, but they're churning out a lot of features. That's all that matters, right? You have this fantastic chat feature that the VP had to have. Unfortunately, it outputs stuff in HTML and no one knows how to read it, and it's worthless. But hey, it's a feature and it was done, so let's mark it as something important. It's like being a hamster on a wheel. You're doing a lot of work, but your princess is in another castle and you're just not moving there. It's a lot of waste. In general, a lot of times, especially as individual contributors, we can feel this way at our company. We're putting as much work as we can into it, but we just don't see what value are we bringing? How are we helping the company? So today we're going to talk about what the real goal of a company is. We'll talk about productivity. What does it mean to be productive instead of just busy? We'll talk about the theory of constraints, how it applies to all this, how to apply it, and what you can do with this information soon, if not long term, assuming you're in a position to do so, and if you aren't, maybe convince your leaders to do so. So, what is the real goal? I'm going to shrink this thing real quick. So the book, The Goal, sought to define this. What is the real goal? But it was very much focused on manufacturing. So since I'm assuming the majority of you are in software, as I am, I really wanted to try and understand, does theory of constraints map to software? And if it does, how? And we'll talk through a lot of that. So let's ask the question though, what is the goal of a software development organization? Keep developers busy? Hopefully not. Write code? Not really the goal, but it is what happens. Innovate? Maybe. Ship features? If they're useless features, is that your goal? Satisfy customers? Maybe, but if you aren't satisfying enough, then what happens? You don't make any money. Although it's cold and businesslike, the real goal of any company is to make money. So let's think about this in a way that feels less businesslike. Imagine that you have an idea for software that's going to change the world. And you need to make it happen, but you know you can't do it by yourself. And you've got a group of people over there, maybe it's all of you in this room, that want to change the world too. You can write software, but you're not going to do it for free. So what do I need? You need money, right? It's obvious. So the goal of a business is to make money so that it can achieve its mission and values. So it's not like make the CEO rich is the goal, but the goal is to make money so that you can do what it is you're set out to do. So let's use Source Allies as an example, assuming Matt doesn't throw me out after talking about this. Source Allies, so this is its vision: be the preferred place of employment for collaborative technologists seeking mastery. This is pretty bold. Why would you want to come work for Source Allies? Because you get to be the best of the best of whoever you could ever be. It lives this vision by focusing on its employees' growth and success. Every individual matters at Source way more than it does at almost any other company in the world. And that's how it really focuses on achieving its overall vision of giving every company that we work with a successful implementation, and in doing so, also leveling up its employees. But it can't do that without money. Sorry, Matt, I wouldn't work here if you didn't pay me. All right, so let's talk about productivity. What does it mean to be productive? We know that we need to make money, but how do you be productive so that you can make money? So how do we measure if software is productive? Lines of code, right? If anyone said yes, I might kick you out myself. Hours worked? Of course not. Well, maybe if you're a consulting company, I don't know. Number of defects? Meaning the low number of defects, not the high. The velocity, right? This must be it. Scrum is all about velocity. That's how you be productive. How about stories, features delivered? So this is similar to the other example. The answer to all these, of course, is no. I really like this quote from Bill Gates. Measuring programming progress by lines of code is like measuring aircraft building progress by weight. I agree with that. So that was a joke. I only included it because it's fun. The theory of constraints defines productivity. And effectively what it says is you're only productive if your actions help the organization meet the goal. What's the goal? Make money. So if you're performing an action that's not somehow helping the company make money, it's not productive. It's that simple. Productive actions are those that increase throughput, decrease inventory, and decrease operating expenses. As you can tell, this is manufacturing talk from a professor. It's kind of wordy, but that's all right. We're going to map it back to software and make it make sense. So throughput. What is throughput? The rate at which the system generates money through sales. Not generates stuff, but actually sells it. So in software, the rate at which valuable working software reaches end users and starts generating business value. So putting a website out there, you're not done. You have to actually sell whatever product you're trying to sell. It's not enough just to create it. What is inventory? You've invested money in things and you want to sell them. Your inventory is all the things you have that you've not sold. So what is this in software? Kind of weird, right? Because traditionally inventory is obviously that box with that product. Well, if you had invested a ton of money for your product management department to come up with all these great ideas and build all these requirements, and it's 10 years until you ever get to them, that's money invested that you're not using. That's inventory. Any code that you wrote, but you can't ship it for whatever reason. Maybe it hasn't gone through QA, so it's sitting in that cycle, waiting to get tested. Maybe it's gone through QA, but, well, we only release twice a year, so we're waiting to ship it. Inventory. It's all inventory. And then operating expenses. So operating expenses are the money spent to turn inventory into throughput. What are these for software? Cloud systems are a great example. All of the tooling that you have are operating expenses. All of the time spent, the salaries of your employees, assuming you're not a consulting company and the salaries are paid because they make the money. It's a very unique place. One of the interesting aspects of all three of these is they're in this order on purpose. Throughput, if you can increase it without doing anything else, is the cheapest and most efficient way to make more money. Decreasing inventory can often help, but it typically requires more investment than just increasing throughput. And operating expenses, anytime you edit these, you are almost always affecting throughput. For instance, one operating expense is salary. If you fire employees, you have a lot less money that you have to spend on operating expenses, but you have fewer people doing whatever it is that makes your throughput. It probably has an impact. It doesn't have to, but it probably does. So there's a relationship amongst these three. There's a requirement to maintain them. So to summarize, any action that improves the system's capability to increase the flow of value or throughput, minimize the amount of work stuck in the system, which is your inventory, and reduce your costs, which are your operating expenses, is a productive action. That's productivity. So as an example, let's talk about Source Allies again, because that's what all my examples are. What does Source Allies sell? It's very unique. It sells the expertise and time of individuals. So as a delivery consultant, my time with a company and helping them become great at what they're doing is what they're selling. So my salary is the amount they're charging, and the money they make is the amount they're charging minus my salary. Pretty simple. What's inventory at Source Allies? Kind of weird. Source Allies isn't a company that says, you know what, your contract's up, get out of here, see you later. We actually retain contractors, which is absolutely fantastic. It's one of the reasons that I said, sure, I'll come join you guys and try that thing out. And anyone who doesn't currently have a partner that they're working with is working on something internal, but there's more likely than not minimal to not enough value being produced by what they're doing. So technically that person sitting there is inventory. The more people that we have there, the less money we're making off of them, the more we're spending, et cetera, et cetera. What else there has operating expenses? This building, the chairs you're sitting in, equipment, all the basic things. There is also a salaries component to it, but it's not every employee. It's the employees that are not consultants. So there are a collection of employees that work without consulting to help everyone consult. That would be an operating expense, their salaries. But as a consultant, my salary is not an operating expense because it is part of what's value is being delivered. It's part of what's making money. So how would Source Allies increase throughput? For sure, reducing your inventory, right? The people that you have that could be making money that aren't, find a partner for them to go to. They go there, they're making money. Poof. No more inventory, increase throughput. New client, to focus on throughput first, new clients with new hires is a net profit. So that's the best way for Source Allies to produce or to increase throughput, increase value. Reducing inventory would be second. Operating expenses would be third. This is a hard one for, I think, a company like Source Allies to really minimize, but it's partially because these are a much smaller amount of the total budget of a company like this than they are a traditional company. So it's not as important. Okay, so now that we know what productivity is, we know what the goal to make money, how does theory of constraints come into all this? So if any of you are familiar with this content, this is probably going to be obvious what I'm going to do here. What is the load that this chain can hold? As much as the string. The string is what the theory of constraints likes to call a constraint. And it wants to focus, it's very important, and it's one of the core aspects of the theory of constraints, is you want to focus on optimizing where your constraint is, not optimizing any other piece. So you look at the whole system, you understand where your weakest point is, and you optimize that. Finding the constraint is an incredibly important part of the theory of constraints. So in this case, if this chain were let's say this one. If the chain just to the left of the string was the software department, and you found a way to increase their throughput by 10 times, they could produce way more features than they've ever produced before. And that string is your QA department. Should that team produce all those features? The answer is no without a change, assuming you can make that change, because all they're going to do is build up inventory behind QA. So your constraint, being the string, is going to stop you from being profitable. It's not going to be worth the time spent. I don't know, cut your software engineers in half? No, don't do that. Turn some of them into QA, maybe? How about automate? Automate the tests. That's the best solution. If you can automate all the tests, then you can do the 10 times plus. But what you're doing is you're taking that string, that constraint, and you're actually improving its capability. And that's an important step in the process of the theory of constraints. And we'll get to those specifics. For now, let's do a story. I had a slide, and I tried this last week, and the slide even put me to sleep. So I've moved it to a story. We'll see how it works out. Hopefully none of us fall asleep. All right, so there's a company, we'll call it InnovateSoft. Super original name. They have tons of ideas, but they struggle to get all of their features or new products out the door. So imagine this rope is their chain of development, and there's something that's just stopping features from getting through. They're falling off the rope. They're not quite making it through it. They're getting stuck. Some of them eventually make it over. You've got a leadership team sitting around saying, guys, what are we going to do here? This is frustrating. We have the best of the best ideas. We're going to be trillionaires if we can figure out how to make this happen. The VP of engineering, product development, bunch of leadership in the company get together and collaborate and say, let's try and figure this out. Let's map the entire flow of what we have and see where actually is the problem. Not assume, just see where it is. Of course, the problem is the engineers just don't have enough time. They have pretty cool laptops though, because the screen is transparent or something. It's definitely not AI, I promise. So they determine the development team's capacity is their constraint. Digging a little deeper, what they noticed, they're just feeding way too many projects onto this team. There's way too much context switching, not just from the projects, but from a lot of other things that are going on. Hopefully there's nothing obscene in these. Oh, that is fantastic. So radiation is how you make a, no. Yeah, that's funny. I didn't even look at that. Okay, so back to the story. They started focusing on how do I improve the development process and how do we help them be more productive? What they found was, again, too many projects are being shoved into their faces. Product management keeps saying, look at this great new thing, look at this great new thing, look at this great new thing. Please work on it. Please work on it. At minimum, they're saying, size it. Tell us how long it'll take. And you're in this infinite loop of constant context switching, and you can't just focus on what the most important thing is. So they made a change. Product management said, fine, we'll stop, which is not realistic from what I've seen, but let's pretend it happened. Now they're just going to work on only the critical projects, and they're actually going to leave the engineers alone. They're also going to make a change within the development environment itself. So there's a lot of defects that are coming in. They're going to actually choose to take some of their engineers and focus them on basically maintenance. And maybe they'll rotate this around because who wants to be the maintenance team? But everyone understands the value of it. And the context switching is incredibly expensive. So having people focus on maintenance and everyone else focus on feature development can be really helpful. They also had a lot of infrastructure problems, build times, the build system, et cetera, et cetera. So they also then ended up building a separate team to manage those. They have a team to manage the problems that are getting in the way of the teams that are trying to get the core features done. This was incredibly helpful to that group, but it wasn't quite working yet. So that one group, imagine they're the big gear, was working better, but all of the other groups still were somewhat getting in their way. So the company decided to have conversations with all those leaderships and say, how can you change so we can maximize the value of what the developers are doing and get out of their way? So the product managers stopped pushing data in. The QA team said, we're going to make sure as soon as something's done, we're ready to test it. It's not going to be a delay. We're not going to say we don't have time. We're not going to say, sure, next month. We're ready right away. Project managers stopped hounding and started helping. They started actually finding roadblocks and clearing them, trying to help everyone be efficient instead of just telling everyone they aren't and everything's late. Incredibly helpful. So all of that being said, there's still more that the company could do. What they discovered is there's information that these developers have, there's expertise that they don't have that they need to be great at what they're doing, to build the next great product, or at least the one they're working on now. So they hired a few engineers or Source Allies consultants in order to come in and share their expertise and level up their internal teams. They also discovered training and tools were lacking, if non-existent, and there were some that would really help this particular project or future projects, so they started investing in those. So they spent money. And the result, fantastic. Profits going up, features delivered going up, everyone's happy, nice smooth flow through the pipeline. Maybe. Customers were happy, they're spending more. Ultimately, they're making more money. Fantastic. Except they suddenly noticed that they produced a ton of features that couldn't actually ship for various reasons. What they then did was say, all right, what we recognized was we had a constraint. We did what we could to improve the system to remove that constraint, and now we have a new one. So they're going to start over. Okay. Well, that story didn't put me to sleep. Hopefully it didn't one of you. This is the infamous slide. So they went through the 5 focusing steps. So this is a key part of the theory of constraints. So the first thing they did, they identified what the constraint was, the development team's capacity. They then chose to exploit the constraint, stop feeding them too many projects, reduce their context switching, create a maintenance team, SWAT team for build times. So they focused specifically on the constraint to optimize it locally without affecting anything on the outside. They then subordinated the constraint, which is a silly word, but this is basically taking all of the other pieces that exist around the constraint and ensuring that they are set up to properly improve to properly feed data to the constraint at the right rate and consume from the constraint at the rate that it needs. So you do everything that you can as the non-constraint groups to actually help the constraint be successful. This is one of the hardest parts for a lot of businesses because this requires cross-departmental coordination at a level politics will never allow. So if you have office politics, this is going to be your problem. And then they elevated the constraint. This is where they spent money, actually invested in more developers, but knew where to spend it, and more tools and training. And then they discovered there was a new constraint, so they repeat the process. So effectively what the theory of constraints says is take these 5, there we go. Take these 5 steps, run them through the first time. Find where your constraint is, do what you can to fix it, rinse and repeat over and over and over again. Continuous improvement. The reality is you aren't necessarily exploiting, subordinating, and elevating every single time you find a constraint. You only want to do them in that order and as much as you need to remove the constraint. So it may be that exploiting is enough and you're at a point where the system works well enough, the constraint is removed, so then you skip just to repeat and you look at the system again. Where's a new constraint? Eventually you will get to a point where you're satisfied with the constraint, you're okay because you understand it and you understand the flow of it, but you never want to get to a point where you stop asking, is that still our constraint? So that comes to what are you measuring, how are you measuring it, and are you meeting the metrics of your value delivery? Okay. Everyone still awake? The story worked. How do we put all this into practice? That was a lot of theory. I have hated SAFe for my entire life until I was doing research for this talk and I ran into these 3 slides or these 3 images, and I realized there's some good things about it. So there's a thing called the value stream map that has been used in manufacturing forever. It's a way for you to clearly understand the flow of materials through your entire system from chain to chain to chain in order to optimize and really see and measure the time it takes for each component of your system until it ultimately gets shipped. You can use them in software, and they're actually incredibly useful. You're not using them in software so much as you are using them at your business level, and then you're digging deeper to understand where are the problems. SAFe actually encourages that you use these, which is great. They made them a little complex, but they are not easy. So this one seems super simple. Well, duh, right? That's what I thought when I first saw this. Yeah, you get a feature request, you release it, whoop-de-doo. But you can dig deeper into this, and that's ultimately what this one is. The idea behind a value stream map isn't to make a complex diagram. It's to actually understand how long it takes to go from step to step, to measure it, and ultimately understand what do you need to improve in order to improve this whole life cycle. So effectively, you can use these to find your constraint. Once you find your constraint, you can make changes to it, and because you're measuring all of this, you can watch how the changes actually impact the flow. If they improve it, great. You may immediately see your next constraint just by looking at these, assuming you're doing the measurements. The measurements aspect of this is the most complex part to implement without adding a ton of overhead or driving everyone crazy. So you got to be careful. I could do a whole talk on value stream maps. Well, I can't yet because I don't really know them, but I would probably love to. So maybe I'll do one of those in the future. So I keep mentioning metrics. So there are three key metrics. Lead time, as I'm sure you've all heard, is actually an incredibly important metric that almost no businesses are measuring. And effectively, this is like for a software company, an idea comes into a software company, however it comes in, and they actually say that's the thing we want to work on. How long does it take to go from that to it's delivering value? I would guess most people would scream if they saw these metrics for their company because, they're in the months to years, I guess decades in some cases, depending on what the idea is. So lead time is incredibly helpful for you to look at. Cycle time, you've probably all seen this in Jira, Rally, whatever tool you're using. This is lead time, but at a stage level. So within a sprint, what's the cycle time from when I set my story to active to when I set it to done? How long did that take? On average, how long is that taking? Is that going up or down? You can watch these metrics. The key behind watching them is not to make sure people are following and meeting certain, expectations on what the minimum time is supposed to be. It's to understand your system, understand how it's flowing, and make adjustments in order to maximize that flow. So work in progress is another one. This is very common in Kanban. It's not talked about as much elsewhere. But if you're measuring how things are going through the system, at any point in time, you should be able to understand how much work is at any one point in the system. So imagine your 10 times productivity software development group produced a ton of new features. If you were actually visualizing work in progress, you can see the inventory sitting there waiting for QA to actually test things. That might be as simple as there's a query in your issue tracking system that just tells you how many things are in a certain state. It's your inventory. Reduce it. But most importantly, you need to track it so you can see those things. All of our tools give us all these graphs, and very few people use them effectively. Some other applications. I mentioned it earlier. I tried to stress it quite a bit. You have to have cross-functional collaboration. You have to work across all departmental boundaries. It's the only way any of this is going to work because you're trying to improve the entire system. And you can't improve the system if everyone is pointing at Department X and blaming them and doing nothing about it on their own because they have to subordinate. They have to do what they can do to improve Department X, assuming Department X is actually the problem. And then once you find the constraint, there are tons of ways to do root cause analysis, but it's usually the tool to use in order to try and understand why is this constraint a constraint. If we can figure out why, we can start coming up with methods on how we're going to approach fixing it. And if we can do that, we can make it no longer a constraint. I have no idea how I'm doing on time. Am I good? Okay, good. All right, so that was all fine and dandy, but what are you going to do with all this? This week, and it's Monday, so this actually works. Have a conversation with your teams. If you're in a leadership group, have a conversation with your direct peers and say, hey, there's this concept of trying to find a constraint of our system. And if we can find that constraint, we can work together to improve it. And then we can actually improve our overall flow and our value delivery. Most individuals in business will be excited about that and want to hear more. Just don't do that slide thing because they'll probably fall asleep. This month, value stream mapping is hard. It's probably going to take more than a month, to be honest, to do it right. But you could start at a smaller level to get comfortable with value stream mapping. So if you're a software company, you have a QA department, just value stream map your QA department. How does a ticket come into the system? How do they decide how to test it, manual or automated? If it's manual, what's the process there? If it's automated, what's that process? Where do they enter it? Do they do automation? If so, where do they get the data? There's a bunch of steps that exist. If you go through all those steps, you can start to see there is a flow that most people probably don't have documented. Once you document it, if you stick measurements in the right place, you can be in a state where you can start to see where it could improve. And like I just said, start measuring. Measuring is the most important. Stop ignoring all those metrics. Actually start measuring, because measuring, understanding it, noticing it change, as well as being able to use the measurements to see how your changes are impacting the system is incredibly important. All right, so key takeaways. Stop optimizing for busyness. We're not here to be busy. We're here to optimize for making money. Value flow. Focus on the whole system. If you improve a small part of the chain and that is not the part that is weak, there's no point. You've wasted effort. It was not productive. Your system's performance is limited by that weak link in the chain. The 5 focusing steps are incredibly valuable in helping you go through your system, and once you find the constraint, understanding how to improve it, and then recognizing there's probably a new constraint. Let's start over. This could be a week-long process. It could be a year-long process. It really just depends. How bad is the problem? What sort of changes do you need to implement? How long does it take to actually see the value of those changes? And most importantly, use throughput, inventory, and operating expense to guide any of the decisions that you make. Are you productive? Is the action that you are doing productive? It is if it's increasing throughput. I practiced last week. I said the throughput like 15 times, but I recognized it. Hopefully I haven't said it today. I saw the word thorough way more than I saw the word through, apparently. All right. Use throughput, inventory, and operating expense to guide all your decisions. That's productivity. You're increasing throughput, decreasing inventory, or decreasing operating expense, because ultimately that's helping you make money, which is the goal. Speaking of the goal, Eli Goldratt wrote the book, The Goal. That is what introduced the theory of constraints to the world. It's a fable. If you've read Lencioni books, it's like those, except a lot longer. And it was written in the 80s. There's some husband-wife stuff in it. It's kind of weird. It's very 80s. Ignore that part. There's actually a movie version. I don't know if you can find it anymore, except the company wants to charge you like $600. It's really good. I saw it at a conference once, and it's classic 80s, but it's good. If you hate reading really long books, there's a illustrated version. It's about 130 pages. So it's all like it's the same book, same content. I haven't read it, but it's all illustrated. If you want to read what I feel is a flawed version of The Goal, the Phoenix Project exists. No spoilers, but this is basically a software group that was struggling to get features out. It's very much a DevOps focused book. So it's trying to convince you that a DevOps team, or at least a focus on DevOps rather than just writing code, is incredibly important. And so they use the concept of DevOps, and what they had set up for DevOps was the constraint, and they had to fix that in order to improve the flow of their system. I didn't like it as much because it focuses on their group, not on the whole system, which feels like it ruins the message, but it's also a fable, so really easy to read. Okay, value stream apps. These are not easy. Lucid Chart and Miro. Miro surprised me, but Miro has a design tool or a diagram tool that actually works really well for this. If you want to make quick, let's just talk about it, database diagrams. Miro also has that in their design tool. I like that. Lucid Chart's probably the one most people use. The value stream mapping book that I have up here, it's by Karen Martin and Mike Osterling. It's probably the book to read if you're going to read a book about value stream mapping. It's not super long. It goes into all the details, and it talks about how to do them right, which is really fantastic. I don't know that they were in tech or understand tech very well because they have an example, but it just doesn't quite work. But it's close. They tried. I appreciate that. So that's the book to read. Otherwise, you can go to SAFE documentation. They actually talk about it. Just don't read any of the rest of it. Sorry if any of you are fans of SAFE, by the way. Actually, if you are, let's go to coffee. I'd love to hear about it. Maybe you can change my mind. Your teammates, like I said earlier, go talk to people at your company. Tell them why you want to make things better and that you want to do it together. That you don't want to blame anyone. You want to make the system better. But to make the system better, we have to do it together. And then there's me. I would love to chat with anyone about this stuff or about anything else. What are your business problems? What are your goals in life? How are you trying to achieve them? I don't really care, to be honest, but it'd be fantastic. So that QR code should go to my LinkedIn. Otherwise, that's my name. You can find me. I'm probably the only one spelled that way. And most of all, thank you. Thanks for coming. It's way down on the bottom. Thanks, WebGeeks, especially, for giving me the opportunity to finally get off my butt and write a speech, write a talk, be able to give it. This has been a ton of fun, a real journey for me. I've never done a public strangers talk in the past, so this is the first, and it was so much fun to do. So thank you very much. Yeah, of course.
Tiny bit further about metrics, specific metrics, and maybe if you can just like name some standard metric like implementations or systems or something that somebody could research further on.
These, without question, are the most important if you're going to look at the whole system and understand how each part of the system is performing, and most importantly, how the changes that you make are impacting that part of the system. So I worked with the Scrum team a number of years ago, and in general, the team itself said, we aren't getting enough stuff done. And I said, well, why do you guys say that? No one's telling you that, right? Management wasn't telling them that at that time anyway. And so what I started to do was just look into it. What could I measure to try and help these guys see they are or they aren't producing enough? And maybe we could find some answers. Cycle time came up. I said, what the heck is this thing? This looks silly, because all of our charts showed nonsense. But mostly what they showed was everything sat in to do or active until the last day or two, and then went to done, assuming it went to done. And I just showed those charts to the team, and they said, well, the testing person quickly said, yeah, guys, you give me everything at the end, and I don't have time to test them. The reason why most of our stuff isn't done until the day or two after the sprint, if not longer, is because I don't get it until the end. I can't see it. I can't even do anything with it until then. So just by looking at that chart, the team made a change. They said, okay, at minimum, if we don't feel like we can get the whole story done before the end of the sprint, let's get the tester involved in a way that they can start at least writing tests, if not testing smaller pieces of it. And all of a sudden, we were able to see the cycle time chart actually change because engaging the QA started to eke out some assumptions that the developers were making about what this needed to do. And it made it simpler in a lot of cases. So they finished the story sooner. So there was a huge improvement that we could quickly see just with that one measurement at a team level.
The developers see this chart,
Mhm.
whatever it is. So that somehow woven into a sprint ceremony, or do developers have access to this constantly? Like, are they getting feedback on a regular basis?
So in my experience, most engineers don't want to look at any of this. Not because they don't like it or anything, but mainly because they have an appropriate fear that as soon as you start looking at metrics, management is going to get dumb and things are going to really start to suck. And so, but the reality is, I know it's in Rally by default. I know it's in TFS or Azure DevOps, as it's now called, and I know Jira has it. There are cycle time charts for every sprint, for every team, and anyone has access to them. Click on reports, there's going to be something called cycle time somewhere, and you're going to be able to pick each sprint and see the graph. So one of the things I actually did once with a team at the end of the year, they wanted to do an overall productivity analysis. So I just printed out all their charts, all their cycle time charts for the entire year. I didn't put any dates on them. I didn't tell them what sprint it was. And I said, pick out which of these are productive sprints, which of these are not productive sprints. These guys had no idea what a cycle time chart was. They were just totally guessing, which is the whole point. It was actually a lot of fun. They did a pretty good job of identifying which sprints were productive by just trying to understand what the charts were doing and really recognize that the most productive sprints, the sprints where they got the most done, were those where they actually completed work throughout the sprint as opposed to all at the end. What we then started to do was we looked at the sprints that were not that productive and we just talked through what happened at each one of these. And so they started to be able to have really solid conversations about making those, what changes can we make to them? So you can introduce these in an event like that, where it's a safe space. You're just very clearly telling them, this is just for us. Let's just analyze this. Let's get better together. Alternatively, you could have them be something you look at a retro, maybe. Ideally, don't include leadership, because leadership does get dumb. Case in point, I used to be a software engineering leader, and sometimes I got dumb. It was sometimes, right, Steve? Only sometimes. Thank you. Appreciate it.
Anybody have familiarity with like door metrics from the? No, that's a new. Okay, cool. So what you're talking about is door metrics. Door metrics
Sure.
is a thing created by Google. It's a system you can put in place on your workflow and your development time, and it will track these specific metrics for you. Yeah.
Cool. Someone there probably found value stream maps and theory of constraints and said, dude, I want to make our stuff better. Cool. It's DORA, like Dora the Explorer. I'm gonna take a note here.
Just like you're saying, like that is our experience.
Yeah, that sounds great. So at a subcomponent level, it sounds like those are incredibly valuable. I wonder, can you apply those broader? They probably aren't from Google necessarily, but. Mm-hmm. Gotcha. Gotcha. And so one of the reasons why I slightly don't hate SAFe as much is because they encourage companies to start to split their company up into what they call, well, I don't know what they call them, but what I will call value columns or value stream columns, where effectively everyone that needs to be involved from idea to ship is in one subgroup. So you have the opportunity now, and the value stream maps help you recognize where those are and start implementing them, because the most complex value stream map means you have a problem. You can probably split your company out and get more value. So now you have an opportunity to say, every time we ship a product in this particular sector or in this specialty, whatever it is that we're doing, we make a ton of money. So we're going to take part of our company and we're just going to dedicate it to that. We have product people that know everything they can about it, engineers that are masters at it, testers that know the whole system, and then we can just ship it independently of the whole rest of it. So you do that across your entire company, you start to deliver value a lot faster. So It sounds like maybe if those metrics were put into place, you could start to recognize we're really slow, but we're slow for all of these reasons. And like the example, it's probably a context switching problem, or there's just too much load. So then you could start to think about how to split.
They would tie into Jira or whatever.
Yeah.
These metrics store would tie more into code pushes.
Gotcha.
Less about the other two.
Sure. So assuming your development team was your constraint, those would be incredible for tracking all of that. Yeah. And if you do continuous deployment, I'm assuming. So that's the best way to get value immediately into the hands of customers. Hopefully it starts realizing value, but measuring that can be really hard too. So none of this stuff is simple, but it's worth thinking through. Other questions? Yeah. Mm-hmm.
Many different things at the same time.
Mm-hmm.
Is that the solution to the constraint in that case, to split those back up into different departments that specialize, or is there like another?
It can be. It really depends on the system. In not knowing the situation, what you're likely are ending up with is engineers that have too much individual load. So if you don't have a team that's focused on your build system and it's incredibly complex and hard to deal with, it's very hard for engineers to focus on the features they're working on and try and maintain the build system. But the whole DevOps movement made it so that was okay, right? Aren't we supposed to do that now? Well, yes and no, right? So you do need experts and you need people to be able to be experts when the system gets complex enough. So in that instance, what you're probably needing to do and what a local optimization might be is just taking the individuals that are responsible for all of these and saying, what if we split ourselves into individual components? Some of us will just be focused on tests, and you could rotate this. Most groups like this would rotate it. We'll do tests for a week. You do code for a week, et cetera, et cetera. Maybe a week is too short, but so now you're sub-optimizing, but you're splitting people's context. And so now you have the opportunity to focus on what you need to focus on. And ideally, you're not all drudging it because you got stuck into the group you don't like. Yep. You could definitely do it within a team. One of my PagerDuty is a tool used a lot, right, to watch production. A lot of teams will use it so that it'll throw an error message when someone has to go deal with some production problem. A lot of teams will rotate who's on PagerDuty. So usually it's by sprint. Every sprint, a different engineer has to worry about all the production issues, and everyone else can just focus on features. They'll still do features, but depending on how bad the sprint goes or how bad PagerDuty bugs them for that sprint. So that'd be an example of something where teams have done that and been pretty successful at it. Yep. Yeah, but chances are if your system is now overloaded all in one department because they became all the departments, it's going to be difficult. You're probably having a product group that's saying, here's all the things we need to do. And as the department, you have to figure out how to get all of that stuff done and ship it and do all the other things you have to do to be successful software engineers. That's a systemic problem. So you won't be able to fix it all, but you can probably make it tolerable by banding together as a group and saying, how do we make this better in our piece? And what'll happen is if you can create the right level of improvements, if people can start to see the enthusiasm and the effort that you're putting in, if they're the right people, they get curious and they start to asking you questions and you start to share all this. They start to say, well, that's really interesting. Are there other places we could also apply things like this? And you'll then have the opportunity to be the experts in improvement. You may be able to make suggestions. Hey, if you guys did this, it would really help us. And we know that because here are all the stuff we did. And here's how that's impacting us. And we actually chose to take that thing you're doing and sort of ignore it because it was creating all this chaos for us. And now they know where they might be able to make an improvement. It's not theory of constraints, but it would work. Good question. Yeah. That you should not be what? So if you think about it, and reading the book actually could probably help this even better. Think about it like a factory. There's one particular machine that receives parts from other systems that are farther up in the chain. They can only process parts at such a rate. If the systems that are prior to them produce parts at a faster rate than they're able to process, it'll just build up. So to optimize that, you make it so that all of the system parts that are before the constraint only produce as much as what that system needs to be optimal in its performance. So the best amount of inventory is the amount of inventory that the constraints can consume. And if you end up in a state where you're building too much, you know it because that if you're measuring work in progress, that's where you're going to see it. There's too much for the constraint to consume. It's building up and up and up. Stuff isn't getting done. That's a point at which you know you have to stop producing, which is the hardest thing to do. And really, it's stressed pretty well in the book. You're basically telling the systems prior to the constraint, stop, just stop doing what you're doing because it's busyness. It's not productive work because it's not helping us make money. And so one of the things they focus on in the book is efficiencies and how each unit had great efficiencies, and that's all they focused on. My efficiencies are fantastic. What do you mean I have to stop doing work? Well, just because that other department over there is slow, you're telling me not to do as much as I should do? All my numbers will go bad. Now I'm going to look bad to the bosses, et cetera, et cetera. But if you look at the system as a whole, them producing 100 parts, if the constraint can only consume 50, is 50 times or twice as much waste, right? So the best amount of inventory is the amount of inventory that your constraint can consume. Now, a lot of times people will say, build a buffer, ensure that there's enough so that if there's some efficiency improvement, they're not sitting around doing nothing. But one of the biggest stresses is be okay with people sitting around doing nothing if the alternative is busyness. Most likely, what they're going to do when they're doing nothing is optimize their local system in a way that improves something. But what you really want them to do is to find a way to really optimize what they're doing to elevate the constraint if they can. Most likely they can't. So in the case of project managers, they're a good example, right? They can hound everyone about dates as much as they want, but that's waste. It's busyness if we already know the system can't produce as much as what the dates are trying to say. So they have to step back and ask themselves, what can I do differently to help the system improve? Maybe I need to track things in a way that the engineers understand. Maybe I can help them use tools like what was talked about earlier in order to really understand their subsystem. So I'm going to stop worrying about the project and I'm actually going to get into the weeds and start helping the engineers deal with numbers and metrics. And I'm going to create charts and do all that for their system. So now I'm not busy because I'm doing what I can to help the constraint maximize its effectiveness, which will allow all the rest of the system to perform better. Does that make sense? Okay. Mm-hmm. Oh, when you initially analyze the system, so if you're using a value stream map, this one's complicated, but not quite. But what you can see is that at each, so what's being tracked here, at each blue box, there is how much time is spent in this phase. And in between each box is how much time does the output from this system wait to go into the next system. If you put a flow like this together, it should take as little as a week, depending on what your flow is and how quickly things come through. But it could take up to a month in order to see how long does it take any part of the system to go from A to B to C to D, and what are those delays. Now, if you don't have enough input data, you'll have to wait longer to ensure that there's enough to be realistic. So if you do this with 5 stories and 4 of the stories went through incredibly smoothly and the 5th one sat at one place for 10 weeks, was that the right system? Probably not. You need more data to feed into it. You want an average. So for a development team, I would definitely say at least a month. It may take multiple months. The hardest part, though, is building the system, getting the measurements in place, and making it so that they're there without getting in the way of the engineers. So you're talking about how long did it take to do something. You don't want to make your engineers sit there and track. How long did it take me to do this task? How long did I work on that piece versus that piece versus that piece? Because that's waste. That's busyness. That's not actually going to bring you what you want. But you can analyze the JIRA data. I know has it. They have a historical system that you can get from the API. So I've actually utilized it recently to build a chart for a team to understand. They put target start and target end dates on every single story for a project they were working on. And they put roughly how many days they thought each one would take. And so they said, well, I guess that metric came from the start and end dates. They wanted to know 2 things: how close or how accurate were our start and end dates? How far off was our start date? And did we ever really meet the end date? And they wanted to see basically a scatter plot to understand this. They then also wanted to know their duration. So that was an independent variable that we could track. So you could see, okay, well, once one thing went off, everything kind of, dominoed into everything being late. So that chart wasn't rosy, but it didn't matter as much because they had a huge buffer and they filled it and they were good. But the duration one was incredibly important, and they got to see the duration estimates were about 50% accurate, almost to the T, which was pretty interesting. Well, 50% feels terrible, but how far off were they, right? So the ones that were inaccurate ended up only being, half to a whole standard deviation off, which in this particular instance wasn't too bad because we're talking 3 instead of 2 days or 4 instead of 3 days. So it was pretty close. Their measurements were small enough that it worked out really well to see that. I then put it on a matrix to see how far. So each quadrant was on time, met duration, on time, didn't meet duration, et cetera. And it was fascinating to see how the dots fell within that. But they had an opportunity to look through all that. That was all in JIRA. So it was just a matter of, there's a JIRA Python library. It makes it super easy to interact with it. You can send it queries to get all your data out. And then Python has all the tools to deal with analysis and plotting. So it was really quick to build and super valuable. But again, that was an opportunity to see where were they, and this was the team wanting this. Well, one of the team members wanting this. The other 2 couldn't care. And so they had an opportunity then to really understand, next time we try this, we're going to make these tweaks based on what happened. Now it took, to your question, it took 4 months for them to go through the project. So the chart was really cool to see at first because it was working. And it sucked also because every time I wanted to look at it again, barely anything moved. So it was really fun to see at the end when everything was actually done and you could analyze it. So it's not a real-time chart, which is what the value stream app is not really trying to be real-time so much as it is, if you go from idea to ship, how long did it take through each stage and where are the slowest components? Now, some components are going to be slow because they are. So if you have, in a manufacturing example, it just takes 2 hours to heat treat something, but it takes 5 minutes for it to go through the rest of them. You know it's going to take 2 hours. That's not necessarily an indicator of a problem, but it's probably your constraint. In fact, in that instance, it definitely is. So you need to make sure the whole rest of the system doesn't feed it too much. But you can also ask the question, do all of the parts that are going into it need to be heat treated? Is there an alternative way we could build the parts so we could just cut that system out entirely? So you start to really ask questions about your whole flow. what parts are necessary, not necessary. But it takes that time and effort to build. Not easy, not quick, but worth the effort.
So thank you very much for presenting. I think you did a fantastic job.
Thank you.
The first time, you did great. Thank you very much. All right, all. Well, that's the end of it. Remember this.